All right, hello everybody. We're going to return to trigonometry today. And today we're going to learn or revisit how to use trig ratios to figure out an unknown angle in a right triangle. So before we do that, let's just revisit what we know so far. And we did this fairly quickly about a week and a half ago. So let's just take some time to review. What we did to learn a little bit about trigonometry was we did some investigations with similar right triangles. Okay, so we drew a bunch of right triangles that were proportional to one another. And they are here right now. What you're looking at are the diagram of these similar right triangles. And we measured the angle at the bottom with a protractor, and we found out that using the protractor, we estimated these to be about 30 degrees. And also we found that the ratio of the height to the base of all of these triangles was equal. That wasn't surprising, of course, because these were similar. And if we have similar triangles, the sides should be proportional to one another, and also all angles within the triangle should be equal to one another. Okay, and we did the same thing over here. Here we had a diagram of these nesting triangles. Okay, and we determined that these were also all similar to one another because all of their angles were equal. And then we filled out this chart, and we here looked at some other ratios, not height to base, but this time we were looking at the ratio of the opposite side to angle A. So that's the one that's across from angle A to the hypotenuse. That's the longest side. And then also the one that's adjacent to angle A in each triangle. That's the one that's beside. So for example, in triangle ABC, it's the one that's side length of 4 to the hypotenuse. And again, surprise, surprise, we saw that all of these ratios were equal. Okay, so again, not very surprising. Okay, and so what we talked about last week, or I guess it was a week and a half ago now, was that mathematicians figured out that this information about the ratios of sides, when you pair up two sides of a right triangle, would be pretty useful to people because these right angles exist everywhere. And if you look around your room, wherever you're watching this video, you'll probably see hundreds, if not thousands, of right angles just in your room. Okay, now when you have three sides in a triangle, there are three ways that you can pair them up. Okay, so we have a picture right here of a triangle ABC, and we also talked about the way that we label these triangles. We don't label them the same, well, we sort of label them the same way that we did with Pythagoras because the hypotenuse is always the hypotenuse, but we introduced these new words called opposite and adjacent, and we used those words to describe when we're looking at one of the non-right angles, the other two sides. So the side opposite to angle A, if you look at where angle A is, here's angle A. Okay, it's the side that's across from it. That's the opposite side. And then if you're looking at the adjacent side, adjacent means beside or next to. So the adjacent side is going to be the side that's beside the angle, but that's not the hypotenuse. Okay, now these labels of opposite and adjacent depend on the angle that you're looking at. If instead I chose to look at angle B, whoops. So now I'm going to look at maybe the red, change my color to red. Well, the angle that's opposite angle B is the one that was adjacent to angle A. So this one, if you go across from angle B, I'll do this one in red, is the opposite side to angle B. And the one that's next to angle B is the one that was opposite angle A. So this is the one that's adjacent to angle A. So opposite and adjacent really depend on the angle that you're considering within the triangle. Okay, hypotenuse is always hypotenuse. It's the one that's across from the right angle. Okay, and what mathematicians did was, whoops, I need to get rid of my pen. There we go. Here we go. They decided that when we pair up two of the three sides, we can do it three ways. And they called these the three trigonometric ratios, the three different ways that we can pair them up. Okay, so the first one, well, they're in no particular order, but the three ways that we can pair them up are adjacent and opposite, and that's called the tan ratio. Okay, so the tan of an angle, and the variable that we typically use for an angle is this Greek letter theta, is equal to the opposite over the adjacent side. Okay. Then the next one is sine. It's spelled S-I-N-E, but we only use the first three letters to abbreviate. S-I-N of an angle is equal to the opposite side, the length of the opposite side over the hypotenuse. And then finally, the cosine ratio. We just use the first three letters again. The cosine of an angle is equal to the adjacent side over the hypotenuse. Okay, and so we looked again at this triangle that we had drawn initially in the investigation. So that's this guy over here, right? And we had a height of 3 and a base of 5. So using our new terminology to label the sides, the height is actually the side that's opposite to this angle. And the angle, by the way, was not 30. We were off by 1 degree. It was 31. And the side that it was the base was actually the adjacent side. So the two sides that we're pairing up are opposite and adjacent. And that is the tan ratio. That's this one. Okay, because that one involves the opposite and adjacent side. So a picture of this exact triangle is basically stored in the memory of your calculator. So I'm going to pull up a calculator right now. Here it is. And one thing that's really important is that you're in degree mode. So if you look at my calculator sort of 2 to the right of shift, the shift button, you can see a DEG. You need to make sure that you're in degree mode. You can also see it at the very top. In very small letters, it says DEG. If you have trouble with that and you're not in degree mode, just let me know and I'll help you out with that. And if you, for example, your trigonometric ratio buttons, sine, cosine, and tangent are here on the right, if you enter in the tangent of 31 degrees equals, you're going to get 0.6. Now, 3 divided by 5 is 0.6, right? And that was the opposite over the adjacent, or the base over the height, okay? So when you have a particular angle in mind, the ratio of the opposite to the adjacent side, or the tangent ratio for that particular angle, is stored in the memory of your calculator. And then not only that, but if you have the ratio, the 3/5, you can actually get the angle. The way that you access that, though, is you have to use something called tan inverse. And it looks like it's tan to the power -1, but it's not actually tan to the -1. And usually what you have to do is hit the shift button, or sometimes it's the second button on certain calculators, and then hit the tan button again. And there it is. And I'm going to put in 3 divided by 5. And there's my rounded to the nearest whole degree. It would be 31 degrees. Okay, so all of that is stored in the memory of your calculator, which is super, super useful when you're trying to solve problems. And we're going to learn today how to find angles. All right, back to here. So we did a couple of examples in class quite quickly, but I've added a few extra. So I'm going to move on to this page over here, and I made this available to you guys on D2L, but if you don't have a printer, you can just write these angles down, or write these triangles down. There's just 3 of them, so hopefully it won't be too onerous. And what we're going to do is figure out how to determine an unknown angle. Okay, So this question says, determine the measure of each indicated angle to the nearest angle. Okay, so for part A, we need to figure out angle A, and for part B, we need to figure out angle B. Okay, now whether you're figuring out an angle or a side length, and we're going to do side lengths tomorrow, the first thing you want to do in all of these types of problems is label your sides with the angle you're using. Now, if you want to figure out an angle, that should be the angle that you're using, because you're definitely going to involve that in your trig ratio. Okay, so here in the first one, we're using angle A. We're using angle A. So I'm going to label my sides relative to angle A. Okay, so the first thing I'm going to do is find the right angle, and there it is, and I'm going to go across from it. That's my hypotenuse. Okay, the opposite angle is the one that's across, or the opposite side rather, is the one that's across from angle A. So that one is right here. That's the 175. Okay, and then the third one, well, it's the one that's left over, is the adjacent, but that's also the one that's beside angle A. That's not the hypotenuse. Adjacent. Okay, so step 1, label. Okay, label sides. Step 2, what you need to do now is you need to choose a trig ratio. And what you need to keep in mind with these trig ratios is that every trig ratio has 3 unknowns: an angle and 2 sides, right? Sine theta, the angle is theta, equals opposite over hypotenuse. Cosine theta equals adjacent over hypotenuse. Tangent theta equals opposite over adjacent. So they all have 3 unknowns. To solve an equation, you need to know all but one. So in this case, you need to know 2 out of 3. Okay, so what I'm going to do, and we talked about this in class as well, but I'll just remind you guys, there's a little mnemonic that you can use to remember the trig ratios. And I suggest you write this down every time you're working with trig. It is so, ka, toa. Okay, and the idea is that sine, the S, is for opposite over hypotenuse, cosine theta equals adjacent over hypotenuse, and tangent theta equals opposite over adjacent. So if you can remember that word, you can remember your 3 trig ratios. They're also on your formula sheet though. Okay, now when we're trying to find an angle, the angle is going to be the unknown, because that's what we're trying to figure out. What that means is that we've got to know the 2 sides. Okay, so if you look at this particular example first, the 2 sides that we know are the opposite side and the hypotenuse. So what I'm going to do is I'm going to look at my SOHCAHTOA and say, which of these 3 trig ratios uses opposite and hypotenuse? And the one that uses opposite and hypotenuse is sine. So I'm going to write down the sine ratio, and make sure to write sine theta. Some people just write sine, they don't write the angle in, equals opposite over hypotenuse. Okay? Third step, fill in what you know. Okay, so in this case, we don't know the angle. That's what we're trying to find, but it's called angle A. So I'm going to say sine of A equals, we do know the opposite, it's 175, and we do know the hypotenuse, it's 340. There we go. And once you fill in what you know, there should only be one unknown. So the fourth step is to solve. Okay, and in this case, we have the ratio and we want the angle. When you have the ratio and you want the angle, you need to use sine inverse. So A is going to equal sine inverse of 175 divided by 340. sine inverse of 175 divided by 340. So I'm going to take out my calculator and I'm going to use the shift button, sine inverse of 175 divided by 340. I'm going to close the bracket and go equals. And that's also 31 degrees. Okay, so this is 31 degrees as well. So we can say that A equals 31 degrees. Okay, so that's that one. Let's look at B. Okay, so we're going to start out the same. With B, we need to label our sides. So we're going to use angle B to label the sides because that's the one that we want to know. And I'll start with the hypotenuse. The hypotenuse is across from the right angle, which is right here. So that's the 200. Okay. The opposite side is the one that's across from B. So that's this one. And the adjacent side is the other one, the one that's beside angle B, that's not the hypotenuse. So that's this one. So my sides are labeled. And now I'm going to choose a trig ratio. Okay. Now I want an angle this time. So again, my two knowns, the two things that I know, have to be the sides. And the two that I know here are the adjacent and the hypotenuse. So I'm going to look at my SOHCAHTOA and I can see cosine is the trig ratio that uses adjacent and hypotenuse. So that's the one that I'm going to pick and I'm going to write it down. Cosine theta equals adjacent over hypotenuse. Okay, and I really highly recommend that you write it down first without putting values, without putting numbers in, because people who do that first tend to make less careless errors. Okay, now I'm going to fill in what I know. So I don't know theta, but that's labeled as B. So I'll put cosine of B equals, adjacent is 135, hypotenuse is 200. Okay. Now what I'm looking for is the angle, and I know the ratio. To access an angle, I need to use the inverse function. And this time I'm going to use cos inverse. So B equals cos inverse of 135 divided by 200. And now I got to go to my calculator. So I'll just clear this. Shift. Got to press the shift button to get the inverse trig functions. And I'll go cos inverse of 135 divided by 200. I'll close the back bracket. Equals, and this is 47.5458 degrees. So if I'm going to round that to the nearest degree, that would be the nearest whole number. The digit to the right of the nearest whole number is a 5, so that would round up to an 8. So this is going to be 48 degrees. So B equals 48 degrees. Okay. All right, one last example before I let you go on your way to practice some of these. Okay, example 2, determine the angle between the diagonal and the longest side of the rectangle below. All right, well, we don't have a diagonal in there, so we should probably draw that. Here it is. There's the diagonal. And we want to know the angle between the diagonal, so that's the line that I just drew, and the longest side of the rectangle. The longest side is the 12. So this is the angle that we want to know. And I'm going to call that theta. Okay, now we're told that this is a rectangle, so this has to be a right angle. Therefore, we can use trigonometry. Okay, and actually, I didn't mention this earlier, but I should reiterate because I did mention it the first time that we talked about this. These trig ratios only apply to right triangles. Okay, so the fact that we're told that it's a rectangle is important here. All right, so again, I'm going to start out. Now I've got a triangle with that diagonal drawn in, I'm going to start out by labeling that triangle. And I'm going to label it relative to theta because that's the angle that I'm trying to find. Okay, so first my hypotenuse is the diagonal because that's the one that's across from the right angle. So it's right here. Okay, my opposite side is the one that's across from theta. So that's the 7. And my adjacent side is the 12. Okay, and then again, so katoa. So I want to know, my unknown is an angle, so I need to know 2 sides because I got to know 2 out of 3. And the 2 that I know here, the 7 and the 12, that's the opposite and adjacent. And the trig ratio that uses opposite and adjacent is the tan ratio. So I'll write out my tan ratio. Tan theta equals opposite over adjacent. And I'm going to fill in what I know. I don't know the angle, but I do know the opposite side, it's 7. And I do know the adjacent side, it's 12. Okay, again, here I'm looking for an angle, but I have the ratio. To access the angle information, I need to use the tan inverse button. So theta is going to equal tan inverse of the ratio, 7 over 12. And that's equal to, well, let's find out. 7 over 12. All right, clear. Tan inverse, 7 divided by 12 equals 30.256 degrees. So rounded to the nearest, what did I say on this one? Did I say 10th? I can't remember if I said 10th or nearest degree. Well, nearest degree would be 30 degrees. Nearest 10th, I'd have to look to the digit to the right of the 10th, which is a 5. So that would be 30.3 degrees. Okay. So what did I say? Oh, I didn't say. Oh, no. Okay. Well, let's round it to the nearest 10th this time then. All right. So that was 30.3 degrees. I should have said. I'll say in the future where I want you guys to round to. Okay? All right, so that's it for this video. We will talk tomorrow about how to use these ratios to find side length.